Okay, so in this video we are looking at patterns, and that basically leads us back to tables and equations. So the best way for me to look at this is to do a question, so that's what I've done. I've got a question from a previous year's exam paper and I'm going to start by drawing myself a table. So I'm going to put that as row and that as number of triangles, and just by looking at the equation or the picture, I'm able to work out that I've got row 1 has got 3 triangles in it, row 2 has got 5 triangles in it, and row 3 has got 7 triangles in it. So if I'm looking for a linear pattern, I found one. I know it's linear because the difference there is 2. Difference between 3 and 5 and difference between 5 and 7, and that's the definition of a linear pattern. You know, if it goes up by the same amount each time, it's a linear pattern. So now I need to find an equation that links R, what I do R to get T. Okay? Or they started talking about row N, so maybe I should use my letter N there. Now, the nice thing about this is that I know that there are things to use in here, but the common difference number is the number that's generally in front of N. And if you think about it, each time I do a new row, there are 2 new triangles coming, so that kind of makes sense. To find out my constant, the best way is to substitute a number in. So T equals 2 times 3 plus C. And look, that I've got my point from one of my points in my table. I could have chosen any point, it doesn't matter. 2 times 3 is 6, so 7 equals 6 plus this number that I don't know, so the number must be 1. So therefore my equation of this pattern is T equals 2n plus 1. Okay, so that's a linear pattern. The next thing is to talk about the quadratic pattern, and that's a little bit harder.